Good morning, students. So already we have completed 9 problems. Let me continue the last session for the problem. That is, I starts with 10th problem. 10th problem. Two moving coil meters. Two moving coil meters M1 and M2. M1 and M2 having the following particulars. Having the following particulars. Having the following particulars. What are the things he has given? R1 10 ohm, N1 30, A1 3.6 into 10 to the power of minus 3 meter square, B1 0.25 Tesla. Also R2 14 ohm, N2 42, A2 1.8 into 10 to the power of minus 3 meter square, and B2 0.50 Tesla. Then what is asking? Determine the ratio of number 1, current sensitivity and number 2, voltage sensitivity of M2 and M1, the ratio of second meter to first meter. Now these are the given things. एक बार पूरा problems देख लो, then after I go for solution. Simple problem है. एक बार पूरा datas देख लो. What is asking? Current sensitivity and voltage sensitivity of second meter to first meter ratio. So shall I go for current sensitivity? Yes. Number 1. For current sensitivity, the ratio of deflection per unit current, theta by I. Theta by I is nothing but NAB by C. How it comes? CD equals to CT. बाहर करने की ज़रूरत नहीं, ना B is equals to C into theta. NAB by C theta by I. फ्रैक्शन ऑफ सेकंड में आप इक्वेशन रेडी कर सकते हो, वो ज़रूरत नहीं हम लोगों को, इतना बस है. So N is the number of turns, A is the area, B is the magnetic field, C is constant. Shall I write IS is directly proportional to NAB. C is the constant. That is nothing but couple per unit twist. निकाल दो इससे? Yes. I can write IS is directly proportional to NAB. ले सकता हूँ मैं? So I go for second meter. Therefore, current sensitivity for second meter to the current sensitivity for first meter. Second meter, N2, A2, B2. First meter, N1, A1, B1. Substitute करो directly. N2, A2, B2, N2 42, A2 1.8 into 10 to the power of minus 3. What is B2? 0.5. N1 30, A1 3.6 into 10 to the power of minus 3. B1 0.25. देख लो इधर ही है गिवन थिंग्स, राइट. 1 जा 2 जा 1 जा 2 जा, these two get cancels, right. A2 get cancels, ये दोनों कैंसिल हो जाते हैं. अब बचा क्या देखो, करंट सेंसिटिविटी ऑफ सेकेंड मीटर टू द फर्स्ट मीटर is equals to, what are the remaining things, 42 by 30. Shall I cancel with what? 6 table? 6 7s are 42, 6 5s are 30. This is 7:5. This is our answer. एक बार चेक कर लो पूरे. वन 1.4 भी लिख सकते हो उसको. 7/5 इज नथिंग बट 5 1 5, 2 बचा, 5 4 20, 1.4 भी लिख सकते हैं. Is it clear? Yes. That is the ratio of current sensitivity for second meter to first meter. अब मैं वोल्टेज सेंसिटिविटी को जाता हूँ. Shall I go for voltage sensitivity? Yes. Now this is for current sensitivity ratio for second meter to first meter. So second one, for voltage sensitivity, shall I write Vs? The ratio of deflection per unit volt, right? Then what is the equation? Theta by, that is nothing but, shall I write theta by V equals to I into R, theta by I into 1 by R. लिख सकता हूँ मैं. Then theta by is nothing but voltage sensitivity, sorry, current sensitivity. Yes, voltage sensitivity is equals to theta by I, current sensitivity divided by R. Already current sensitivity निकाले सो है. I go for directly ratios. Therefore, voltage sensitivity for second meter to the voltage sensitivity of first meter, current sensitivity of second meter, resistance R2. ऊपर जाता है R1 divided by IS1. Right? So, shall I write ratio of IS2 by IS1 into R1 by R2. Right? इसको मैं थोड़ा दूर लेता हूँ मैं. Voltage sensitivity is equals to current sensitivity divided by R. सही है, बेसिक इक्वेशन है. इसको अच्छी तरह से निकालो. R1 by R2. Then you go for substitution. ये आपका इक्वेशन हो गया. Alright? Then I go for substitution. इधर जगह यूज कर लेता हूँ मैं. Current sensitivity by resistance. निकाल दो इसे. So यहाँ पे वोल्टेज सेंसिटिविटी को करंट सेंसिटिव बाय रेजिस्टेंस, मेरे को सब्स्टिट्यूशन को इजी हो जाता है. राइट? यस. सो वोल्टेज सेंसिटिविटी फॉर सेकेंड मीटर टू द वोल्टेज सेंसिटिविटी ऑफ फर्स्ट मीटर इज इक्वल टू करंट सेंसिटिविटी रेशियो 7/5 आया था. 7:5. दिस इज 7:5. R1 10, R2 14. सही है. R1 10, R2 14. So 2 2s are 2 5s are 2 7s are. Otherwise, shall I write 10 by 14, 70 by 70. How much? 1:1. This is my answer. voltage sensitivity for second meter to first meter is 1. That is nothing but 1:1. This is my answer. आप 1 भी लिख सकते हैं ऐसा. Simply it is 1. Right? Now this is the simplest way to approach what? The voltage sensitivity and current sensitivity ratio for second meter to first meter. Already आप calculate करें. So first this 7/5, this is nothing but 10, this is 14, 7 into 10 70, 5 into 14 is nothing but 70, 70 by 70 is 1. Right? Shall I go for the next? 11th. पूरे सिंपल है, आप अच्छी तरह से अप्रोच करो बस. Then I go for 11th problem. 11th. प्रॉब्लम देख लो क्या दे सो. ऑलरेडी पूरे प्रॉब्लम्स आप देखे तो लास्ट 2 वीडियोस देखे तो आपको मालूम हो जाता कोई दिक्कत नहीं है. Isn't it? Yes. Next one, 11th problem. In a chamber, a uniform magnetic field of 6.5 Gauss. A uniform magnetic field of 6.5 Gauss. He has given 1 Gauss equals to 10 to the power of minus 4 Tesla. 1 Gauss equals to 10 to the power of minus 4 Tesla. He has provided. Is maintained. An electron is shot into the field. An electron is shot into the field. With a speed of 4.8 into 10 to the power of 6 meter per second. Shot into the field with a speed of 4.8 into 10 to the power of 6 meter per second. Normal to the field. That is perpendicular to the field. Full stop. Why the path of the electron is circle? Why the path of the electron is circle, and determine the radius and frequency of revolution of the electron. Right. बाद में पूछता हूँ, is the frequency depends on the speed of the electron. हम बोलेंगे लास्ट को इक्वेशन प्रूव करने के बाद. Right? When the charged particle enters in the region of magnetic field normal to the field, it describes a circular path. Reason क्या है? The force experienced by the charged particle in the region of magnetic field is balanced by centripetal force. Hence, it describes a circular path. This is my first answer. So, when it describes a circular path, what is the radius of that circular path of the electron and frequency of the revolution? So, we know that R equals to mv by qb. qb is nothing but q is nothing but electron. Magnitude of the charge is taken as positive A into B. Then you substitute the value. R equals to mass of the electron 9.1 into 10 to the power of minus 31 kg, that should be understood. Velocity 4.8 into 10 to the power of 6. Charge of the electron 1.6 into 10 to the power of minus 19 coulomb. Magnetic field 6.5 Gauss. 6.5, 1 Gauss equals to 10 to the power of minus 4 Tesla. 6.5 Gauss, 6.5 into 1 Gauss. 6.5, 1 Gauss equals to 10 to the power of minus 4 Tesla. Right? Substitute karo. 16 ones are, 16 threes are. Right? Then R equals to 9.1 into 3 divided by, अब क्या होता है देखो, 10 to the power of minus 31, it's minus 19 minus 4 minus 23, minus 23 ऊपर चले गया plus 23, 23 plus 6 29, minus 31 29, 2 carry 1, this is 10 to the power of minus 2 meter. चक्कर लेको एक बार. Right? Divide करो, we can get the answer. Right? This is nothing but 27.3 divided by 6.5 into 10 to the power of minus 2 meters. If you divide it, it becomes what? 4.2. Radius equals to 4.2 into 10 to the power of minus 2, 4.2 centimeter. Check करो एक बार. .2 centimeters. Right. This is our radius. Then after this I come across frequency of revolution. इसको reason तो मालूम हो गया circular path के लिए. When the charged particle enters into the region of magnetic field, normally it describes a circular path because the force experienced by the charged particle in the region of magnetic field is balanced by centripetal force. Hence, it describes a circular path. Right? A minus 2 है. Minus 2 is nothing but centimeter. Say, shall I go for frequency of revolution? Yes. देख लो एक बार. Right? Then frequency of revolution. Frequency of revolution. दो प्रॉब्लम्स को मर्ज करे सो यहाँ पे frequency of revolution F is, we know that T equals to distance by velocity, distance traveled in a particular direction, that is nothing but for one complete rotation, 2 pi r by v, 2 pi r, 2 by v, r equals to mv by qb. अभी करे सो है, v get cancels, so 2 pi m divided by qb. Right? I need the frequency. Frequency equals to 1 by time period. This is qb divided by 2 pi m. उसको उल्टा कर दे तो मैं qb divided by 2 pi m. Q is nothing but charge of the electron. Eb divided by 2 pi m. The frequency of revolution is independent of speed of the electron. Right? Here it is independent of speed of the electron. So and then you substitute the values. Right? So what is E? 1.6 into 10 to the power of minus 19 coulomb. Magnetic field that is nothing but 6.5 was 6.5 into 10 to the power of minus 4 Tesla. 2, 3.14, mass of the electron 9.1 into 10 to the power of minus 31 kg. Right? Then after solving this one with the help of what, जहाँ पे रुक जाते हैं वहाँ पे आप कैलकुलेटर यूज कर सकते हैं. So your answer is 18.18 into 10 to the power of 6 hertz. This is your answer. Right? 18.18 into 10 to the power of 6. This is your frequency of revolution. Right? देखो एक बार. Then what is the one more thing? The frequency of revolution is independent of speed of the electron. कहीं पे भी नहीं है देखो speed. Right? Shall I go for the next? Yes. निकाल दो इसे. Right. Next 12th one. Next 12th one. What the 12th problem tells? देखो. 12th problem. क्या बोलता देखो 12th one. A circular coil of 30 tons. दो पार्ट बनाए सो a circular coil of 30 tons. A circular coil of 30 tons and radius 8 centimeter, carrying 8 centimeter, carrying a current of 6 ampere, carrying a current of 6 ampere, is suspended vertically, in a uniform horizontal magnetic field, uniform horizontal magnetic field of 1 Tesla. Find the field lines makes an angle of 60 degree. The field lines makes an angle of 60 degree, makes an angle of 60 degree with the normal of the coil, with the normal of the coil. Calculate the counter torque that must be applied to prevent the coil from turning. Calculate the torque. Calculate the torque acting on the coil. Acting on the coil. Counter torque means the torque which is available, which opposes the rotation of the coil, that is called counter torque. Simply I can write the torque acting on the coil. Second one. Would your answer change if the circular coil were replaced by planar coil? if the circular coil were replaced by planar coil of some irregular shape, planar coil of some irregular shape of same area. Now this is my problem. लिखने के लिए वास्ते बड़ी है वो, थोड़े सेंटेंस उसको मैं काउंटर टॉर्क वगैरह कट करे सो फिर फॉर इजी अंडरस्टैंडिंग. So a circular coil is having the 30 turns and radius 8 cm, carrying a current of 6 ampere, suspended vertically in a uniform horizontal magnetic field of 1 Tesla. The field lines makes an angle of 60 degree with the normal. This is the important factor. He has directly given alpha. Calculate the torque acting on the coil. So counter torque means the torque created on the coil which makes the prevention of hot rotation. That is nothing but counter torque, opposite torque. Then after that, if the circular coil is replaced by planar coil of some irregular shape of same area, is there any change in the answer? देख लेंगे solution. Given जरूरत नहीं है, पूरा इधर ही है. The torque acting on a current loop, torque tau equals to mb sin alpha. One more thing, alpha is given directly, normal sentence है. M, that is nothing but NIA. I into A, n number of turns, NIA, B sin alpha. Substitute करो. Number of turns, 30 turns. Right? So, shall I write NI, area circular coil, pi r square, B sin alpha. Substitute करो अब. What is the current? 6 ampere, 3.14 into radius 8 centimeter, 8 into 10 to the power of minus 2 whole square. What is the magnetic field? B1 sin 60. Sin 60 is root 3 by 2. So 30, this is the shall I write 180 into 3.14 into 64 into 10 to the power of minus 4. This is root 3 by 2. Say right. Then I make it torque tau equals to, so 180 into 3.14, 64 by 2, 32 into 1.732 root 3, 10 to the power of minus 4. By using the calculator, if I go for substitution of the values, so our answer is 3.133 Newton meter. Right? 3133 into 10 to the power of minus 4 हो जाता, 3 जगह हटा दे तो 3.133 Newton meter. This is nothing but your problem. Right? एक बार देख लो पूरा. M is nothing but I into A for a number of turns NIA. Right? यहाँ पे normal sentence इसके वास्ते यहाँ पे underline करे सो देखो. This normal itself indicates that is nothing but alpha value. Is it clear? Then second part में देखो. The torque depends on what? Area of a loop. It is independent of what? The shape. अब प्लेन कॉइल ये क्या ले? Area same रखे सो है. Area is kept constant. Hence, there will be no change in the torque value because area remains the same. Torque is directly proportional to area. If the area is same, torque is same. Hence, the torque is independent of what? Shape. It depends on what? Area. Hence, the torque remains same. That is second answer. The torque is independent of what? Shape. It is depends on what? Area. By keeping the area same, the torque is also remains same. एक बार पूरा glance करो. Now these are the what 12th problems, then थोड़े problems हैं, थोड़े additional problems है, आप लोगों को conversion of गैलोमीटर into वोल्टमीटर के 2-3 problems है, वो भी कर लेंगे. एक बार देख लो पूरा अच्छी तरह से, कूल से देख लो. Shall I go for next one? Yes. Then 13th one. निकाल दो इसे, खाली सब्स्टिट्यूशन करना है, कैलकुलेशन और कुछ नहीं है. So you can easily understand the problem and go for the what? The formula, direct formula based है. Next, I go for conversion of गैलोमीटर into एमीटर and वोल्टमीटर. एडिशनल प्रॉब्लम से ले सही हो. सो ऑलरेडी हम लोग थ्योरी करे सो है, 1-2 प्रॉब्लम कर लेंगे वहाँ से. राइट, देन देख लो. A galvanometer coil has a resistance of 12 ohm. A galvanometer coil has a resistance of 12 ohm. 12 ohm, and the meter shows full scale deflection, and a meter shows full scale deflection, full scale deflection, full scale deflection for a current of, for a current of 3 milliampere. How will you convert the meter into a voltmeter of range 0 to 18 volt. Now this is our conversion of galvanometer into voltmeter. Right? Given things क्या क्या है देखो. Solution. The resistance of the galvanometer G 12 ohm. The current through the galvanometer full scale deflection 3 milliampere. What is the range of the voltmeter? 0 to 18 volt. What is the requirement? High resistance. To convert galvanometer into voltmeter, we need the high resistance that should be connected in series with galvanometer. How much high resistance is required? That is our problem. देख लो. We know that R equals to V by Ig minus G. V 18. What is Ig? 3 into 10 to the power of minus 3. What is G? 12. 3 1s are 3, 6 are 18. Shall I write 6 into 10 to the power of 3 minus 12? Then substitute करके देखो कितना हो जाता. So 6000. R equals to कितना होता है? 6000 minus 12. 6000 में 12 निकालो. Right? 6000 minus 12, 8, 9, 5988. This is your answer. Say, so 5988 ohm. This much of the high resistance is connected in series with galvanometer. Then the galvanometer acts as a voltmeter which read up to 18 वोल्ट। सिंपल है, राइट? एक बार देख लो, ग्लांस करो, right? Then the last thing of the topic problem, conversion from galvanometer into ammeter का एक है। Say, is it clear? Shall I go for the last problem of the topic? Yes. देखो last one, 14th problem. 14th problem, it is based on conversion of galvanometer into ammeter के लिए, conversion of galvanometer into ammeter के लिए। देखो, a galvanometer coil has a resistance of 15 ohm. A galvanometer coil has a resistance of 15 ohm. And the meter shows full scale deflection for a current of 4 milliampere, full stop. How will you convert the meter into an ammeter of range 0 to 6 ampere? Now this is our problem, right? देख लो एक बार पूरा, ग्लांस करो। और एम इज टू कन्वर्ट गैलोमीटर इनटू एमीटर। एक बार देख लो पूरे प्रॉब्लम्स को। सॉल्यूशन क्या क्या दिया सर? देखो, रेजिस्टेंस G गैलोमीटर 15 ओम, फुल स्केल डिफ्लेक्शन IG 4 मिली एम्पियर, 4 into 10 to the power minus 3 amp. The range of the ammeter I equals to 6 ampere. What is the small resistance which is connected in parallel with galvanometer? That small resistance is also called shunt resistance. So we know that S equals to G into IG divided by I minus IG. Say, so this is 15. What is IG? 4 into 10 to the power of minus 3. What is I? 6. 6 minus 4 into 10 to the power of minus 3. Right? S equals to 16 into 10 to the power of minus 3 divided by, shall I write 6? If the subtracting term is having single digit more than 10 to the power of minus 2 power, then you simply neglect it. अगर आप subtract भी करें वही आंसर आता है. Shall I write 10 into 10 to the power of minus 3? Then S equals to 0.01 ohm. This is your answer. This is 10 to the power of minus 2. Simply this is minus 2, that is nothing but 0.01. Now this is a conversion of galvanometer into ammeter. Subtracting term is single digit with 10 to the power of more than 10 to the power of minus 2, then the term can be neglected. अगर subtract करें तो भी आंसर इतना ही आता. चेक कर सकते हैं आप. Now these are the problems belongs to moving charges and magnetism. So authentically I can say that the theoretical section ends. आप एक चीज छोड़े थे यहाँ पे, that is nothing but cyclotron. सो नेक्स्ट जो नए टॉपिक स्टार्ट करते हैं वहाँ उस टाइम पे साइक्लोट्रॉन का एक्सप्लेन करके वी गो फॉर व्हाट द नेक्स्ट कंटिन्यूएशन टॉपिक। वो तो ऑलरेडी लास्ट बार सिलेबस में डिलीट करे थे, आपको वो नीट के लिए अगर यूज़ होता दैट इज सिंपलेस्ट। ऑलरेडी उसका थ्योरेटिकल पोर्शन हुए सो है, सर्कुलर फॉर्म जो है पूरे 99% इक्वेशन से मैं खाली एक इक्वेशन चेंज कर। इज इट क्लियर? अगर कुछ भी डाउट्स रहे तो कमेंट सेक्शन में लिख सकते हैं। आई होप दैट आई हैव डन माई ड्यूटी, दैट इज मेक ऑलमोस्ट ऑल द प्रॉब्लम शुड बी मेड ईजियर। अगर कुछ भी डाउट्स रहे तो आप कमेंट बॉक्स में लिख सकते हैं। Is it clear? Yes. Shall I continue with the next class? Yes. Thank you.